So one that was really exciting is underground mining. So I would say that's one of the most challenging environments for any autonomy system. So I'm talking about actually kilometers underground in tunnel systems. They have loaders and trucks that need to be able to navigate, and these are really difficult environments. And if we go back to sort of the landmark analogy for a localization, if you're trying to use, obviously satellites are out, there's no lane markings. You can try to detect the edges of the tunnel walls, but for one thing, they're quite homogeneous, meaning that one section of tunnel looks like another section of tunnel, or it can change quite rapidly as material falls off the tunnel walls. And it can be very dusty in harsh environment as well. So the LiDARs and cameras, they don't hold up so well in really harsh environments, but also if it's really dusty, they just can't see. So the subterranean environment, we actually are able to record what's meters beneath the tunnel floor, and that's a really good place to pull data for localization.
We're going through something absolutely historic.
Technologies across the board are growing exponentially.
It's a disruption that's going to completely redefine the way businesses compete.
In the next decade, we're going to lose 40% of today's Fortune 500 companies.
The exponential growth of computing is continuing.
AI is nowhere near its full potential.
Whether you like it or not, that the future cannot be stopped by anyone.
Hi there, everybody. This is Mark Verbenkov, and you're listening to episode 129 of the Future Tech and Foresight podcast. So today we're going to be revisiting a topic that's been on the podcast a number of times, and that is the transformative world of autonomous vehicles. So over previous episodes, we've of course discussed the technological innovations and challenges of self-driving cars, and delved into the intricacies of long-haul trucking automation more recently. But now we're about to go a little bit deeper into this subject, exploring the sensors and the technologies that are pivotal in making autonomous vehicles a reality, and specifically long-haul trucks. So I assume by now that most of you listening are more than aware of the kind of revolutionary potential of autonomous vehicles in general. But I think that autonomous long-haul trucks in particular are a really interesting aspect of the industry to pay attention, in particular because and I think many others, think that they will become ubiquitous much sooner than their urban autonomous taxi counterparts. But also, as all of us, I think, really came to understand during COVID, the logistics and transportation industries are so pivotal and vital to the economies and kind of livelihood of economies around the world. Autonomous long-haul trucks really have the promise to reshape specifically the logistics industry. I think that that's why it's such an interesting thing to pay attention to. So joining me today is Noah Gedrimas. He's an expert in autonomous technology. We'll be discussing some of the new innovations in the autonomous vehicle space, the innovative ground positioning radar technology produced by GPR, and the current and future challenges in the field of autonomous driving. So as the Vice President of Strategy at GPR, Noah spearheads the commercial strategy and partnerships with a keen focus on pioneering advancements in autonomous driving. His journey in this field includes significant contributions to the development of ground positioning radar technology, which is a groundbreaking innovation for precise vehicle localization. Noah's expertise is not just confined to GPR. His tenure at Continental Automotive saw him deeply involved in the development of autonomous vehicles tailored for various operational design domains. And we definitely explore that a little bit more in the podcast itself. I really enjoyed my discussion with Noah. I hope that you find some value as well as interest in the topics and ideas that we discuss, and hopefully get a little bit of a better understanding about autonomous vehicles and self-driving vehicles in general. Hi there, Noah. Thank you very much for coming onto the podcast today to talk about autonomous vehicles. I think it's a topic I've touched on maybe 4 or 5 times, but each time that somebody comes onto the podcast, it gets more and more interesting. So thanks for taking the time today to come on and talk about this.
Yeah, well, thanks for having me, Mark. I'm really excited to talk with you and your audience about it, and share what I know.
Awesome. Well, why don't we get started with your initial interest in autonomous vehicles? Like what brought you to the space? Was there any kind of like unique, I don't know, technological marvel that you saw before that got you into the space, or was it some kind of interesting personal story that got you into it?
Um, I'm very much an engineer. I really love engineering. I've known from a very young age I was going to be an engineer, and always been fascinated by how things work, how to make them better, how to build things like that. Kind of grew up as a mechanical engineer, yeah, tearing cars apart when I was 13, 14 years old and working on tractors and things like this.
Hmm. Hmm.
And once I made it to university, I started learning more about mechatronics and robotics and found this sort of emerging field of autonomous driving. And um, if there was kind of a big aha moment for me, it was watching Chris Urmson's one of his keynote sessions. I think it might have been South by Southwest, but this was, man, 12, 15 years ago or so, and hearing him talk about how challenging of a problem it is. And I really like big problems. I like things that are really hard to solve. And I think that autonomous driving might be the most challenging engineering um, problem that our this generation faces. So I think that's how I ended up in it. And then the more you work in the space, the more you appreciate the others that work in the space and the technology, and it kind of pulls you in. So yeah, I mean, it's I guess a labor of love, you could say.
Well, I think that's the only way to do something
Yeah.
that you like, right? Yeah, I mean, I first heard about autonomous vehicles many years ago as well. I think there was the I can't remember the exact name of it, but there was this large competition in, I believe it was the California desert, where there was a race in order
Yeah.
to see. I think it was like 100 kilometers or 100 miles or something like that. And the first year, everybody failed, and I think the second year, like one or two companies succeeded, and then next year, like 80% of all the companies succeeded. So there was
Yep.
certainly a milestone there, but I think that also like got many people's like spirit involved. They're like, oh, like this is exciting, this is interesting, and all the interesting applications across society kind of flowed from there. For me, anyways.
Yeah. That's the DARPA Grand Challenge.
Yes, yes, yes,
And I think it
absolutely.
was maybe $2 million was the first year, was the kind of reward. And all the Carnegie Mellon robotics, and then some really big companies were involved too. I think Oshkosh and um, I believe Caterpillar was involved, and a few other defense contractors. Um, yeah, there's actually a novel I'm reading now that I found. It's called Faster, and it's a fictional story kind of around the DARPA Grand Challenge early, and it's a fun book. So if you're interested in the DARPA Challenge, I forget who wrote it, but yeah,
Well, I'll put it up on the show notes if anybody's interested.
yeah,
Maybe we can start off with kind of the latest innovations within autonomous vehicles. So, I recently had another guest on to talk about autonomous vehicles, and we touched on that a little bit, but maybe we can dive into that a little bit more, because I think that's something that the audience would be interested in hearing, like the latest innovations, if there's been any like large milestones. It's obviously something that's in the news quite a bit, but specifically with regards to the technology, I think that'd be interesting for people to hear.
yeah. Well, it's such a rapidly evolving space. That there's always new technologies and new methods being applied. Two that jump out at me is the role of simulation.
Mm.
I think that the industry is getting a lot better at working with simulation and using it in practical ways. So, simulation was always going to be a big part of solving problems like this that are so open-ended, where you have so many unknown scenarios that can happen, and you want to test in lots of different ways that are similar to, your training data. Uh, but really, I think there's been a lot more focus recently on using the training or using the simulation for the prediction aspects and the behavioral aspects, and a little bit less on the perception side has been, at least what I've noticed. And I think that makes sense because, especially the way cameras and LiDARs and radars for that matter operate in the real world, um, the sensor models that they're using are always going to have bugs and flaws. And so I don't think it makes sense to apply the simulation in that space as much on the early perception, and it makes a lot more sense higher upstream in in the AV stack towards the planning aspect, the prediction, and to some extent the actuation. So I think that the simulation, we're seeing the engineering teams getting better and better at using those and not making the same mistakes more than once, which is really the biggest goal of a test and validation and a simulation environment, is really learning from the experiences and applying that to your whole stack.
Mm-hmm.
And yeah, and I'd say that the GPUs are a big part of that as well. So the work that NVIDIA is doing, and to some extent Tesla as well in that space. I think the other big innovation or thing that seems to be expanding is radars. So there's a lot of higher resolution radar technology now, and I'm talking about surface radars that can see hundreds of meters with a higher resolution. Specifically, there's one use case that's extremely challenging for highway autonomy, and it's detecting road debris. And so there's some road debris that you could drive over and some road debris that you can't. So an example is maybe there's a soda can in the lane, and you don't want your semi truck to slam on the brakes because there's a soda can. But if there's a tire, let's say, that's something that you would need to slow down or go around. And so being able to detect those features or those objects at a range of hundreds of meters is a massive challenge. And the new radars seem to be able to perform this classification. So that's another really big technical innovation that's coming around.
Really?
Those are two that jump to mind, but
yeah. Well, yeah, that makes perfect sense. I haven't heard of that specific example before, or put it in such a way, but it makes sense, because for us it's so easy, right? There's no real, I don't know, conscious thought that needs to go into it. It's just like, okay, it's either a soda can or a tire or something that we need to avoid. But I guess for machines, for AI, these things are a little bit more challenging.
The range too, you need to be able to do it at range. So, being able to tell, a truck can take 100 meters to slow down from 70 miles an hour, often much more. That's in a worst case sort of hard braking scenario. So it needs to decide pretty early if it needs to change lanes. So not only do you need to see what is that object, you also need to know, is it in your lane or not? And that can be a challenge at that kind of range, knowing just 1 or 2 meters to the right, and it could be an object that's on the shoulder that you don't need to slow down for. So it's really a big challenge to be able to detect road debris at range. And people, human drivers hit road debris all the time. So it's not like we have it totally figured out, but that's something that's exciting though, is the capabilities of the radar at that kind of range.
And I think I asked of my other guests, but how does AI start to play now with autonomous vehicles? I mean, of course, it's one of the key technological components of making this full technology work, but it's been almost exactly a year since ChatGPT came out, and this new wave of hype and excitement about AI. Of course, maybe ChatGPT is not super relevant for autonomous vehicles, but how has the developments within AI over, say, the last couple of years been key for autonomous vehicles?
Yeah, that's a good question. I think what ChatGPT shows, or what really impressed me about it, was its ability to some extent generalize. So to take training data on something similar and apply it to something new. And that's something that will be needed for autonomous driving. When you talk about some of the weird edge cases that autonomous vehicles can find themselves in, I kind of have a story of a demonstration I did when I was in South Carolina, maybe 6 or 7 years ago. I was showing a level 4 highway autonomy system from Continental, where I used to work, called Cruising Chauffeur. And I was testing on I had I think like a US senator or someone, I was giving a demonstration of the technology on this road. And he was asking me questions, and I, was in the driver's seat, but I didn't have my hands on the wheel, and the car was, driving itself, using its sensors to see what's going on. And I was explaining about the different SAE levels, SAE level 2, 3, 4, and what my role is as the operator in those cases, and explaining that the big challenge for level 4 is the edge cases, for all the things that can happen once every 100,000 or million miles, the vehicle needs to be able to deal with. That's really hard to train. And he said, oh, one edge case or one thing that happened to him that was interesting, he wanted to ask me about. He said, how will the vehicle react to gator tails? And I said, what is a gator tail?
Yeah.
And I'm not kidding. About 20 seconds later, the tread off a semi-truck tire, like on a trailer, came flying off the back of this truck. So the tread like had separated from I guess the belts of the tire, and because it was so hot, and went flying off the truck and almost hit our car. Went off on the shoulder. And you said that's a gator tail. I said, oh my gosh. I was like, honestly, we'd never thought of that. But that's something that could happen, and that thing could have been laying on the road.
Right.
And so the brute force approach is like, okay, so now we know about gator tails, so we'll go and we'll train AI models on gator tails to detect these pieces of tire on the road or realize that's a potential danger and then deal with those. But that's just one kind of edge case. And then there's all kinds of other things that happen like that. And you can't possibly have training data for everything. So having some ability to generalize a little bit and say, this piece of road debris could potentially be dangerous, even though I don't know what it is and I've never seen it before, that's really that big leap of generalizing. And that's what people do. Another example is like there was a video of a tanker truck that had flipped over on the road and spilled fuel, and then the whole road was on fire. So there was flames, and there were still open lanes, but people weren't driving through sort of the fire.
Yeah.
It's, that was another case where I was thinking, well, our automated vehicle, how would it know not to drive through fire? That's something that to us is very obvious, but it needs to generalize and understand that. And there's just lots and lots of those cases. And once you start looking for them, you see more and more and more. And really the only approach that I think has any real shot is the AI, having that, sort of generalization of saying, well, I saw 3 other cars drive through that puddle, so it must be safe to drive through that puddle. It's not too deep, let's say. So that's probably where I think we'll see it. And then the other space that AI is really important is prediction. So I think a lot can be done with rules-based algorithms. And that's nice because it makes it easier to safety validate your system. But one challenging test case is pedestrians that are walking towards the road. So, for example, if you're going 45 miles an hour and there's a crosswalk and you have a pedestrian walking up to the crosswalk, if you did a simple sort of trajectory-based math problem, you would say, pedestrian's moving at 3 miles an hour and I'm moving at 45. If we both continue on our vectors, we're going to have a collision. So you might stop. But as a human driver, you might notice that the pedestrian turned his head and looked at you and, and kind of acknowledged that the car is coming. So you can tell that the pedestrian will stop at the shoulder. Mm-hmm. That's something that is just, if not impossible, extremely difficult to do with rules-based algorithms, where you really break it down. All of the, like, if I see that the, pedestrian's head turned 30 degrees, then it means they recognize me. And the AI models are proving to be really, really good at these cases, these sort of prediction cases. So I think that's where we'll see that AI get brought in. And the real challenge there is going to be safety validating that, because these AI models, at their core, they're kind of black boxes. You really can't quantify how they're doing what they're doing or verify that they will always give the correct answer or the same answer even. And so that's a really huge challenge for the industry is, leveraging the benefits of AI, but finding a way to make it safety critical.
Yeah. Yeah. And I think that's like if I speak kind of as a general outsider or member of the public even, I think that's the thing that is the most critical for public acceptance of these vehicles, right? Because we're so used to human drivers and human drivers make errors. But if there's an autonomous vehicle, I think it's going to be, and I think it's been said that they're going to be more highly judged than any human driver. So the So the rate or the error rate it has to be so low, right? Like significantly low, 10 times, 100 times. I'm sure you have those figures.
Yep.
Compared to human drivers before, not even like regulators, but before just the general public is going to be accepting these things on the road ubiquitously or at scale.
Yeah, no, that's a really good point. I've always thought that argument of it's statistically safer is like to get into this robotaxi than it is to have a taxi. It's like be that as it may, and maybe that's true, maybe it's not. There's all kinds of reasons that's not true, but it doesn't change the public viewing of a robot that hits somebody or kills someone. And I think one thing that'll be really interesting is the first, I call it active fatality in autonomy. So we've had a few fatalities that were sort of passive, in meaning that the vehicle failed to react. So it needed to react, it needed to stop, it didn't stop, or it made a mistake in that way. But it is also possible for the vehicle to make a judgment that's active and ends up, steering onto the sidewalk and hitting someone, or something like more active, or sort of driving off the road into a ditch and hurting passengers. So I think that'll be a lot harder for people to empathize with. I think we can all kind of envision, I was distracted and, didn't see this, and this somebody ran a red light, or maybe not everybody, but it's easier to empathize with that over there was sort of an error in the code that somebody didn't understand, or a localization error, which we can talk about, where the vehicle thought it was here, but actually it was in the wrong lane and was driving into oncoming traffic. And these things are possible. So that will really be a day of reckoning, I think, for autonomy, to see how serious some of these companies are and some of the legislation. So
yeah, and I think to that point, if there's any if there's, I mean, the examples out there now of whenever some of these fatalities happen, the amount of articles and the amount of press coverage is it's pretty phenomenal, even when it's not the computers or the AI's fault. It's humans not taking charge, or humans not, it's typically human error, but purported or reported as the AI or the car's fault. So yeah, it's going to be, I can only imagine just how much press coverage there will be when there's one of these active fatalities. I do want to go back to the point that you made about localization, because of course this is GPR's kind of bread and butter. So maybe you want to touch on that a little bit more, because I don't think this has really come up on the podcast before in previous conversations. So why don't we just start off with a little bit about GPR and the technology that you're working on, and then how that relates to the importance or even why localization is so important.
Yeah, absolutely. So localization is one of sort of the core functions of automated vehicles, and at its simplest, localization is how autonomous vehicles know where they are relative to features that matter. So when I say features that matter, that the main one is the driving trajectory or the lane center, right? And there's lots of different localization methods or modalities, whether it's a GPS-based system, or it can be cameras or surface radars or LiDARs. And actually all of these methods, they all rely on landmarks or data of a known location. And so I like to explain that, because it explains a little bit how GPR works and why it's more robust. So examples of landmarks, one of the simplest ones might be lane markings, the pane on the road. So when you're using lane markings as a landmark, you're using usually a camera, could also be a LiDAR on board the vehicle. It detects the position of the lane marker relative to the automated vehicle. So it might say, I see a lane marker 1.4 meters to the left. And then from there, it extrapolates that the feature that matters, that the lane center must be 1 meter to the right of there. And so 0.4 meters. That's how you'd use a lane marking. Other types of landmarks for LiDAR-based solutions is often the corners of buildings. It can be telephone poles. It could be the curb, things like this. In the case of satellites, of GPS, you're using satellites as landmarks or space marks, really, but knowing your position relative to a satellite and then at space. And since all these localization systems are using landmarks of a known datum, if you're an engineer kind of working in the space, trying to think, okay, what kind of landmarks do I want to use? You come up with some criteria. And the first is that you want those landmarks to be easy to detect and not easily blocked. So usually lane markings are pretty easy to detect. The camera can see them. However, they can get blocked by, other cars. It could be debris on the road, snow, adverse weather, things like this. Secondly, you want your landmarks to be resilient over time. So you don't want them to wear off the road. So that's where the lane markings can wear off. Similarly, if you're using, say, trees as landmarks, which you wouldn't think you would intentionally use, but often LiDAR picks up trees, the leaves fall off the trees, and now you have issues using those. And that's kind of the second criteria. And the third is you want the landmarks to be cheap and easy to maintain, or at least that data layer. So we're using sort of a big LiDAR point cloud of an entire city. That becomes very expensive to maintain. So really, those are kind of the three criteria that you want. And all of the landmarks now that are being used, besides the GPR landmarks, which I'll talk about in a minute, they're all susceptible to the adverse weather in the environment. They're susceptible to being blocked by other vehicles and other things on the road. So if you have a LiDAR and you're trying to see the corner of a building or a telephone pole, and there's a semi truck in front of you or alongside your autonomous vehicle, you can't see them anymore. Maybe you're mapping a parking garage and you're trying to use a LiDAR system. If there's cars parked in the parking garage, you might not be able to see all of the same features that when you come back later, you want to match to. So GPR stands for ground positioning radar, and it works fundamentally the same as these other localization modalities, but we're using subterranean data. And when I say subterranean, I mean meters beneath the surface of the pavement or the road. Up to 3 meters deep. So at its core, that is the most important thing to know about GPR, is that our data layer is underground. And since it's underground, it's protected from the environment. If we can see through a meter of concrete, we can easily see through snow or rain or mud, debris on the road. We never have to worry about cars or trucks getting between our sensor and our data layer. So it's always accessible. And having a data layer that's always accessible really changes the game for localization. It means we have the highest availability of any localization modality, so we can always offer centimeter level accuracy of the vehicle relative to the HD map or the features. And that's really enabling autonomy in a lot of spaces where up to now they haven't been able to get the driver out of the loop. So yeah,
that's really interesting. This has come up on the podcast a couple of times, specifically when we're talking about, say, autonomous trucks that have to go through, well, I guess in the States, miles and miles of distance, and the weather or the environment can change so drastically from 1 hour to the next. It can be, I don't know, maybe sunny at the beginning of their journey and snowing, or some sort of hailstorm near the end of their journey. And I can only imagine that the sensor systems are going to be confused, or as you said, they're not going to be able to pick up that kind of relevant data. So this, in my mind, as I understand it, seems to avoid the entire kind of environmental issue when specifically we're talking about long haul trucking that's impacted by these environmental changes.
Yeah, so the long haul trucking is a very interesting use case. And I know you just had Robert on from Too Simple, and you talked about this a little bit. And I think that the long haul trucking is a very attractive early stage level 4, because at its simplest, it seems like an easy space to automate, because you just maintain the lane in this case. But where that space gets really difficult is dealing with the fallback path or the minimum risk maneuver, minimum risk condition. So I know Robert mentioned you can't stop in lane, and that's true. So NHTSA in the US has said it's unacceptable for a autonomous vehicle to stop in lane on the highway. If it has a failure, it has to pull over to the side of the road. And that's a very hard problem to solve for automated trucks, because that means that if the vehicle leaves its operational domain, let's say, so maybe it's not designed to work in snow or fog or different sun conditions that can wash out the camera. If there's an event where the truck does end up in that situation, which you can't guarantee it won't, it could be an unexpected storm or a dust event or something, it has to be able to continue guiding itself until it can safely pull over. So this is a space where GPR is, being investigated now, is to enable that fallback path for the level 4 trucks, because we can use the GPR system to keep the truck in the lane, even if you lose, all LiDAR camera and GPS capabilities, which is really important for that fallback path. And on the highway in particular, you can rely on the surface radars, which can deal with the adverse weather a lot better than LiDARs and cameras can. So if you have a GPR system that can guide the truck, maintain the lane with centimeter level accuracy, and still have your free space and forward detection from an automotive radar system, like a 77 gigahertz radar system, you really have a powerful tool for minimum risk maneuvers and pulling the trucks over, if not just guiding the trucks during normal operation. But that's really I worked on the level 4 trucking for a few years when I was at Continental. And that was really where the biggest challenge was the fallback path and, the minimum risk condition, much more so than just, being able to operate on, sort of a sunny day in Arizona or Texas.
Right. That's interesting. One question I did have was, okay, so obviously if you're looking at, say, 3 meters, 3 meters or 3 feet below the surface?
3 meters, 3 meters, 2 to 3 meters, yeah.
Right. Obviously, not much change is going to happen underneath the surface of the road. But there are, of course, earthquakes, which I would assume would be one of the only things that are going to be shifting that ground in a short period of time. How would GPR deal with that? I'm assuming you guys have already dealt with that before.
Yeah, that's a great question. So that comes up a lot. We talk about that as like, well, what if the ground does change? So first off, let me say we would love to test in an earthquake, and we don't have test data from an earthquake, but it's something that would be interesting. However, our expectation is that the localization would actually work quite robustly in that case. So the way our matching algorithm works is, we're taking a radar return or a set of radar returns from the radar in operation, and we're extracting features that we can then match to features in the pre-existing map. And the ground, it actually does change its radar return quite frequently from things like moisture content, even the temperature and the humidity of the air, because the sensor's not touching the ground. There's an air gap there, and that can have an effect. And so we have a lot of signal processing and algorithms that sort of normalize, the old GPR data to the data being collected today to do the matching. So it's not like if there's a small minor change to the ground, it's going to cause us to not be able to match anymore. The ground does change.
Right.
Yeah. And some of the operational domains that we're working in, we know that the ground's going to change quite dramatically. So one of those spaces is mining. So some of the surface mining, specifically in South America and Australia, and underground mining as well, for that matter, these trucks are 450-ton trucks in some cases, and they're creating big ruts and really tearing up the ground quite dramatically. They often have to regrade the haul roads or add material. And so we have a mechanism of doing real-time change detection and updating the map. So maybe as each truck goes by, there's a 10% change or a small change in the map data. We're able to update it over time and compensate for changes. Now on road, our expectation is that the maps hold up, for years. But in these off-road cases, there's many cases they're actively digging those areas. So we have to be able to sort of crowdsource or from the fleet update the maps.
Yeah, that makes sense. Um, Regarding the kind of vehicles that you guys would be offering the ground position radar to, is it relevant for all autonomous vehicles, like urban vehicles, which I think is going to be the largest piece of the pie in the future, of course. Autonomous long haul trucking is, of course, the most obvious example that comes to my mind. You just talked about off-road vehicles. Are there other sectors of the autonomous vehicle industry, like I don't know, commuting public vehicles, for instance, like shuttles, etc., that are more relevant? Like who are you guys offering these radars to?
Yeah, so we work with quite a few different industries, and some of the industries we pursued, but most of them came to us, which is really quite exciting. So there's definitely a gap in robust safety critical localization in lots of different autonomy spaces. And I was really shocked by some of them because I kind of consider myself an expert in the field of autonomy, and some of these spaces I'd never even heard of before I started working with GPR. So one that was really exciting is underground mining. So I would say that's one of the most challenging environments for any autonomy system. So I'm talking about actually kilometers underground in tunnel systems. They have loaders and trucks that need to be able to navigate, and these are really difficult environments. And if we go back to sort of the landmark analogy for a localization, if you're trying to use, obviously satellites are out, there's no lane markings. You can try to detect the edges of the tunnel walls, but for one thing, they're quite homogeneous, meaning that one section of tunnel looks like another section of tunnel, or it can change quite rapidly as material falls off the tunnel walls. And it can be very dusty in harsh environment as well. So the LiDARs and cameras, they don't hold up so well in really harsh environments, but also if it's really dusty, they just can't see. So the subterranean environment, we actually are able to record what's meters beneath the tunnel floor, and that's a really good place to pull data for localization. So that's one that was really exciting, where they're trying to apply the above ground mining to these underground cases. Another space that's really exciting is the seaport automation. So they have autonomous cranes and autonomous, they're called AGVs, that take ISO containers from the ships and sort of take them to the stacking, to the stacks. And these currently, most of them are guided using infrastructure. We'll actually embed sort of magnets into the pavement or chips that can be read by sensors on board the vehicles. But this kind of has the downside of you have to install sometimes tens of thousands of these transponders in the ports. Right. Some ports, they can't actually do that because the pavement can't withstand the added holes in it, I suppose. And so this is a space that they reached out to us and said, this is somewhere that your technology could really add a lot of value. Of course, you brought the passenger transport. So electric shuttles is a case. We have two customers that are heavily pursuing that space. So you can think like the 15 passenger electric vehicles that maybe operate at slower speeds, 25 miles an hour and under, and sometimes are on a defined route. So with GPR, it's very easy for us to map those routes out. So say you wanted to go around a city center and a college campus, you can just navigate drive a vehicle manually once, and then you have that area mapped. And you can use the GPR track almost like a train track, like a rail. So you can drive it once and it'll follow that path with centimeter accuracy. So that was another interesting space. Defense is really exciting as well. So in the defense space, we have a couple customers, working on sort of platooning or moving military vehicles in these convoys. And GPR is exciting for that as well, because you can use some of the lead vehicles to create maps for follower vehicles. And you can do beyond line of sight platooning. And actually, that's something, you saw my mug, but this is from Localizing, who was working on it a few years ago before they closed up. So that was another kind of cool space for that. So there's just a lot of really interesting things. And And then, of course, there's the automotive and ADAS use cases, and the robo taxis. So, Cruise and Waymo and Zoox that are working in these spaces, that often have to do a lot of remapping. We can aid in those spaces as well. So, really been a broad um, a broad application of the technology, and really that's changed how we develop it as well. Where before we were really targeting making it automotive focused and building it to automotive standards. After having so much sort of satellite or different industries approach us, we've created a more generic product that we can apply to lots of different vehicle sizes and shapes, different durability requirements. You can imagine what goes on a haul truck in Australia being different than what goes on a package delivering robot in Austin. So
Yeah, that's super interesting. For me, when I first started getting interested in autonomous vehicles, and I'm still, on the fringes. I'm by far an expert on this industry, but I was exposed to autonomous vehicles like robo taxis, and then you start hearing about there's also autonomous ferries, and there's long haul trucking, and there's even autonomous guided robots for farms, like whether they're weed killers or planters or pickers or whatever. The space is quite enormous. So I can only imagine that your technology would be used by many different of these, I guess, satellite industries.
Yeah, that's exactly right. I have a special respect for the companies working in autonomy that are bringing real value right now. And there's for every one company that's doing that, there's 10 that have big ambitions and big aspirations to bring real value in the near future. But the space like the autonomous mining, what Caterpillar, Komatsu, Hitachi, decades they've been operating some of these autonomous vehicles, the agriculture, the autonomous tractors, the seaports with the autonomous AGVs that have been operating for some of them over a decade. These spaces are really appealing to apply technology because they understand their business case well now, and they can say, in the case of the mining, they can say, we have these areas we can't apply the current autonomy technology because of they're heavily GPS based right now, and they deal with a lot of solar storms and ionic events in South America that can cause the GPS systems to go down. And so they're able to easily kind of quantify and say, if you can offer localization in this space or in these areas, we have a market right now, and you can put your GPR system on these vehicles, and that's really appealing. Whereas some of the whether it's the long haul trucking or the some of the automotive spaces, those are emerging markets, and they will come, but it's we might be solving the localization problem or helping enable the localization, but there's other challenges in those spaces as well that need to mature before that market's ready for widespread adoption. So
yeah, I think that's something you brought up, a really good point about the current uses of autonomous vehicles that are already in current use. I think that's something that many people that are outside of the space don't really give enough focus to, right? Is that because I think there's just so much press coverage of say Tesla or the vehicles that are within urban centers like robo taxis, etc. And there's just not enough coverage of all these other industries that have been, as you said, in use for in some cases decades, right? I lived in Oslo for about a year, let's say 7 years ago or something like that, and they had autonomous guided ferries. I was like, whoa, what? Yeah. I thought that this was many years away. So it's interesting to on the podcast especially to hear about these real case studies where these industries are actually being used, or the technology is being used in the industries. It's quite interesting. Maybe that can tie into kind of the last section that I like to talk about on the podcast, which is the things that are coming up in the future, typically 5 to 10 years from now. is the time range that I like looking at. But where do you see well, ground positioning radar, but also the whole industry as a whole moving in 5 to 10 years? Do you think we'll reach, at scale, ubiquitous level 4 autonomy for all vehicles, or is that still going to be 20 years away or something like that?
Yeah. So first off, the for the ground positioning radar, this is very rapidly in the next couple years going to be applied across all of those vehicles and a few others I didn't mention. And I think it'll very rapidly expand some of the operational domains of where these vehicles are operating. As we build maturity and scale, the cost will come down pretty quickly for the GPR technology, and it'll be applied to even more markets. So I really think that it's going to revolutionize the autonomy of a lot of these different industries. I would say for level 4 autonomy as a whole, what we're going to see in the next 5 to 10 years and what to really look for is the operational design domains expanding. And that's really what I think needs to be asked more when we're talking about what this company is doing or what that company is doing, is what is the operational design domain? How are they limiting it, and why are they limiting it in that way? So some of those cases that have been operating for decades, whether it's in seaports or the mining case, let's say, the way they can enable that is they run in protected environments. So they have areas where there are no pedestrians, there are no human-driven vehicles. And so that's a lot very easy for them to just sort of hand wave away and say there is no prediction aspect required because there's no human operated vehicles or those spaces. Similarly, why is it that the robo taxis in a lot of cases are always operating in cities where the top speed can be quite low, say 35 miles an hour and under? And I think that comes down a lot of times to the minimum risk maneuver, the fallback path. So what we can see now is that if there's an issue with one of the vehicles, they often can just stop in lane and turn on their hazard lights. It might be inconvenient for other drivers on the road. It might be bad for press, but nobody gets hurt. So really, those operational design domains of keeping the vehicle under a certain speed, operating where there's really a lot of HD maps. I'd like to see expansion into weather, more adverse weather scenarios. So some of these robo-taxi deployments moving to the northeast of the United States, hopefully. So I'm in the Boston or I'm in the Detroit area, but our company's out of Boston, and both of those are northeast cities. We have snow and adverse weather. So I think we'll see some expansion in those spaces. And it'll be really interesting to see what happens in the passenger car market. So Mercedes released their level 3 system this year that operates in certain areas in the US. It'll be interesting to see if other companies follow suit in the automotive space. Yeah, there's just a lot to watch. And one thing that maybe is a little bit scarier to think about is how humans are going to react once autonomous vehicles are more prevalent. And when I was working on this commercial semi-truck autonomy, the long-haul trucking, when I was at Continental, I got my commercial driver's license so I could learn how to drive a truck. And I did a couple road trips with a fully loaded semi-truck, just enough to learn that this is way, way, way harder than it looks to do. And so part of that was I would stop at truck stops and I would talk to different truckers and things. And on not just one, but on a couple occasions, I had some of the truckers tell me if they saw a truck without anybody operating it, they would run it off the road.
Really?
Yeah.
Okay.
Yep.
Wow.
Yeah. And that really kind of took me off guard. And, I kind of said, well, wait a minute, these are doing sort of the trucking that nobody really wants to do, these long haul across the country. It's not going to this area or that area. You'll be able to just run your truck in local areas, which sounds great. But I think we are eventually going to deal with some malicion in the autonomy space. And that's not something that I think the industry's had to deal with yet. And that'll be really interesting to see. how that, how you technologically sell this. And I think we've seen maybe a little bit of it with the package delivery. So there's been
Right.
some vandalism of some of the Starship robots you see kind of getting pushed over and things like this. And I don't know, maybe 5 years is too soon for some of that to come around, but there's definitely something to be said about people, pedestrians, cars reacting differently to automated vehicles than human-driven vehicles. And yeah, that'll be really interesting to see how that plays out.
Yeah, fascinating and maybe a little terrifying if they don't do it right, if they don't
Well,
run off
I mean,
a giant semi vehicle in the right way. Also, the scale is so much different compared to these, AGVs delivering food to a large semi delivering, all sorts of goods.
Kind of building on one kind of fun question that you might enjoy for some of your audiences. I like to ask, my friends and family, would you pay less or more for an Uber that was autonomous? So would you pay a premium to not have a driver, or would you pay a premium to have a driver? And it's been about 50-50, actually. Some people said, oh, that'd be great if I get my Uber and not have to talk to anybody ever. And then other people said, well, it sounds dangerous, or I like talking to my Uber driver. So I think that'll be a big indicator of how receptive the market is because if you can't charge a premium for it, I think it's really going to be difficult.
Mm-hmm. Fascinating.
What would you do, Mark? Would you pay a premium, you think?
It totally depends on the day. I'm what's the term? I'm an introverted extrovert or something like that. I love working on my computer and I love looking at all this tech, but every now and then, I do need to go out there and interact with people. So I think it completely depends on the day. But this is also a conversation I've had with many people in the past, not specifically with autonomous vehicles, but I remember the first time I really started getting interested in automation, it was about the automated waiter, right, or the automated restaurant. And I had a debate with a close friend about, well, like, this is great. Like, we can save waiters, this type of, long hours, exhausting work. They don't need to deal with, horrible clients at their tables. And then my friend was saying, well, I hate this idea, right? Like, I go to a restaurant because I want to have, good food, but also an interaction with a human being. So, I think you're right. There's no real easy answer, and it depends on the individual. But I think this is something really interesting to think about. I hadn't thought about this with regards to autonomous vehicles that much. So this is definitely maybe a really good place to end the conversation on and think about it a little bit more. And I'm sure people listening to it will think about it as well. Thanks for coming on, Noah. It's been very interesting. And I'll have to have you back when some of these guys, or maybe the first time that we hear about a trucker driving a truck off the road or running the truck off the road, I'll have to have you back to see what you guys are thinking about that.
Yeah, I hope that day never comes.
Yeah.
But I really enjoyed talking with you, and thank you for having me.
Absolutely, a pleasure.
Well, thanks for listening to this week's Future Tech and Foresight podcast. If you like what you've heard here, there are, of course, a number of ways that you can support the podcast. The best way would be to leave a review on Apple Podcasts or give a rating on Spotify, which you can find a step-by-step explanation for on the futuretechandforesight.com website. Alternatively, feel free to leave a comment either on the episode show notes or the YouTube channel where you can see video recordings of the interviews. And finally, if you are part of an organization that is aware of the disruptive and transformational impact that emerging and future technologies will bring and want to know more, please get in touch to hear about the strategic foresight services that we offer and how we can help future-proof your organization and take advantage of the phenomenal opportunities available to survive and thrive in the future.
A lot of future-shocked people and future-shocked institutions in our society are simply overwhelmed.
Once there is superintelligence, the fate of humanity may depend on what the superintelligence does.
Science fact is catching up to science fiction.
The first truly intelligent machine will be the last invention that humanity needs to make.
The only scarcity that will exist in the future is that which we decide to create ourselves as humans.
Within a 10-year design revolution, we can have all humanity living the highest standard of living anybody's ever known.
Progress is accelerating at an exponential pace, and it's going to reach a point where progress is so fast it's going to be a singularity.
We are probably one of the last generations of Homo sapiens.
Every single headline points to the birth pangs of a Type 1 civilization.